Welcome everyone to another video for pre-calculus. So we are going to start a new chapter which is polynomial and rational functions. And in this video particularly we are going to talk about quadratic functions. So a polynomial function is a function in this form, right, given here, such that the coefficient that we have here, these coefficients are real numbers and the exponents are whole numbers. So these exponents are whole numbers. And also, if this is a polynomial of degree n, then we need to make sure that the leading coefficient or the coefficient of x to the n is not 0. Otherwise, if this is 0, then whatever the other highest degree, that would be the degree of the polynomial. So if it's degree n, then the coefficient of x to the n must not be a 0. So here are some examples of polynomial function. So the 0-degree polynomial is called a constant function. That means we just have f of x equals a number, where we can also write x to the 0. That's why it is called 0-degree, and we don't have that variable. Degree 1 polynomial is called the linear polynomial, and it's the example here, negative 3x plus 5. So the degree of x, the highest power of x, is 1. The next one is quadratic, which is degree 2. The highest power is 2. The cubic, which is degree 3, which means the highest power is 3. And quartic, which is degree 4, so that the highest power is 4. So those are some of the examples. And then we could also have the higher degree polynomial functions. So now in this video, we are going to focus on degree 2 or quadratic function. So a polynomial function written in this form here, okay, ax squared plus bx plus c is called a quadratic function. One thing important here again is a cannot be 0, because if a is 0, then this second degree term will go away and that becomes a linear function. So it's okay to have this 0, b 0, and c 0, but we still have to have a as a non-zero number, because this is a quadratic function, means we should have a degree 2 polynomial. So again, all those coefficients are real. And then if we are finding the zeros of the function or the x-intercept, the real x-intercepts for that is given by solving this quadratic equation here. Usually we see a quadratic function in two different forms. The first one is called general form, if it's written in the form ax squared plus bx plus c. We also write it in the standard form, or sometimes it is also called the vertex form, which is a times x minus h squared plus k. This is also called a vertex form because we'll find the vertex of the parabola of the quadratic function, the vertex of the graph, just from here. So this number here, h and k, represents the vertex of the parabola. So there are few properties or the features of the quadratic function. The first one is, if this leading coefficient a is positive, then the graph will open up like this, okay, or it's concave up. If a is negative, then it is concave down, or it opens down. This h and k is the vertex of the parabola, which means there's the turning point, so the graph will turn at that point. There is a line which is called the axis of symmetry, that is the vertical line that goes through the vertex. So the equation of that line is x equals h, the h or the x coordinate of the vertex. And also a quadratic function will have a maximum or minimum if the function is opening up, or we have this D point here, the lowest point, then in this case we have the minimum. If the function is opening, if the graph is opening down, we have this highest point on the graph, which is the maximum. So in this case we have no minimum because this goes to the negative infinity. And in this case, we don't have a maximum because this goes to the infinity. So we have either mean or max depending on whether a is positive or negative, okay? So now let's look at an example. So the first example, we are going to find several things here. The equation is given in general form. Okay, so this is the equation. Now we are asked to write the function in standard form or the vertex form, which is f of x equals a times x minus h squared plus k. So we are going to change this one into that form. That's called the standard form. So in order to do that, we have to do completing a square, and I think you are familiar with performing completing a square. Okay. But I'm going to show you how to do this. So let's do this in the next page, and we'll come back here and we'll write it again. So our function, the given function is f of x equals 4x squared plus 8x plus 3. Now, to do the completing square, what we have to do first is we have to make sure the coefficient of x squared is 1. And we have 4 here. So we really cannot divide on both sides by a number because we just still want f of x here. So whatever we do, we just do on one side. So instead of dividing by something, what we do is we'll factor out that coefficient so that we have 1 as the coefficient of x squared. So we are going to write this as f of x equals, so we'll factor out 4, and then we get x squared plus 2x, and then we'll keep this constant by itself out here. So we're not going to factor out anything from that constant. Now the next step is to do the completing square. So the easy way to, there's a small trick or the technique to do that. So what we usually do is x squared plus 2x. Now we are going to add a number squared minus subtract the same thing so that we are not changing the value of the function. We add a number, we subtract the same thing. That means in overall, the value of the function does not change. It just looks different, okay? So the number that we add here is the number which is half of this coefficient, half of the coefficient of x. So we have 2, so half of 2 is 1. So we'll put 1 here, and then we put the same thing here. Now what happens is, so if we have a squared plus 2ab plus b squared, then we can write this as a plus b squared. So that's what we are trying to do. When we added a number which is half of the coefficient of x, then this one takes this form right here. Now we can write this as the square of a plus b. Okay, so that's what we are going to do next. So we have f of x equals 4 times. Now this quantity right here, this one, we can write that as x plus 1. The quantity is squared. Then we have minus 1 and then plus 3 outside. Now we'll just distribute that 4. So you get f of x equals 4 times x plus 1 squared minus, when you multiply by 4, so you get 4 plus 3, and that gives us f of x equals 4 times x plus 1 squared minus 1. So this is in the standard form or the vertex form. So we are going to write that in our previous slide. So the function in the standard form is f of x equals, we have 4 times x plus 1 squared minus 1. So now this takes this form, the standard form. So one thing that we have to be careful is here we have x minus h in the standard form. So if you want, you can write that x plus 1 is squared as x minus negative 1, and then write it as a square. But usually what we do is when we have that in that form, when we write the vertex, so we just write it this way. So the vertex is h comma k. Okay, so usually, so when we have a minus here, we just take that number. That means we have a plus here, so we take it as a negative. Okay, so it's negative 1 comma, and then we keep this as whatever we have. So if you have x minus 1 is squared, then we would take 1. So we just switch the sign, okay, for that number. So that is the vertex. And now the next thing is axis of symmetry. So once we get the vertex, this is usually what I suggest always to do. Just draw a small shape of the graph. So this is positive 4. We have positive 4. So A is positive. That means our graph opens up. So it looks like this. So now the vertex that we got here, the vertex is -1, comma -1. Now the axis of symmetry is this line, the vertical line that goes through the vertex, and the equation is x equals h. So h is -1, so the axis of symmetry is x equals -1. Now since the graph is opening up, we know that we have a minimum. So minimum, and the value of the minimum is the y coordinate of the vertex, so which is -1, and it occurs at x equals -1. Okay. Now the next thing is finding x and y intercept. Finding y intercept is super easy because when you look over here, this is the y-intercept. Y-intercept means when we put x equals 0, what is the value of the function? So when we put x equals 0, this term becomes 0, that term becomes 0, and then we just have that 3. So the constant term is the y-intercept. Now, if we have the equation in the standard form, then what we need to do is we need to plug in x equals 0 and then find what the y-intercept is, okay? But we already have it in general form, so this is the y-intercept. So y-intercept is, so when we write y-intercept, we write 0, comma 3. So 0, comma the number. Now for x-intercept, what we need to do is we need to take this function, set it equal to 0, and then we have to find the solution of that quadratic equation. So let's go ahead and do that in the next page, and then we'll write it here again. So in order to find the x-intercept, so we are going to take this function 4x squared plus 8x plus 3 equals 0, and then we are going to solve this. So we know we can factor these. The factors of this quadratic expression are, the factors are 2x plus 3 times 2x plus 1 equals 0. Then this means 2x plus 3 equals 0, or 2x plus 1 equals 0. Now if you solve for x here, so subtract 3 and divide by 2, so we get x equals -3/2 or -1.5, and then from here we get x equals -1/2. So the x-intercepts are -3/2, comma 0, and -1/2, comma 0. So let's go ahead and write that in the previous slide here. So x-intercepts are -3/2, comma 0, and -1/2, comma 0. Now we have y-intercept, we have x-intercept. The next thing is domain and range. Remember, this is a polynomial function. So for a polynomial function, domain is always all real numbers, so -infinity to infinity. Now for the range, I'm going to go here and again look at my graph. So this is how the graph looks like. That means this is the lowest point on the graph. So the minimum y value possible is -1, and then there's everything is above that. So our range goes from -1, which is included because it's the vertex, so it's on the graph, -1 to infinity. Now again, to write the interval where the function is increasing and decreasing, I'm going to look at my sketch again. I know that the function is decreasing right here because when we go from left to right, the graph drops down. So from here, so this part of the graph, okay, and then it is increasing right here. So from right from the vertex, this is increasing, this is decreasing, this is increasing. When we write the interval, we write on what x values, the function is increasing or decreasing. So the function is increasing on the interval from this point to the right. So this point is -1 to the infinity, and it is decreasing on the interval over here on the left from -1. So we write from -infinity all the way to -1. Now the final thing that we are going to do is we are going to graph this function. So we have all the information. We know the shape of the graph. It's going to open up. we know the vertex, we know the x and y intercept. So we are just going to put this information here and we'll draw the graph. So the first thing that we are going to put on the graph is the vertex. So the vertex is -1 and -1. So it's right here. This is the vertex. Then the next thing we are going to put is the x-intercept. So it's -1/2. So it's somewhere here. And the other one is -3/2, which means -1.5. So somewhere here. And then that is kind of like sufficient just to draw sketch the graph. But if we want, we can also put the y-intercept, which is 3. So it's right here. It's the y-intercept. Now by symmetry, if this is the line of symmetry, okay, so this is the line of symmetry. By symmetry, we have a point from the axis of symmetry 1 unit to the right here, then we should have another point on the other side of that line. So that's by symmetry, okay. Now if we connect these points, then we can draw our parabola going this way, like that. So this is the graph of that quadratic function. Now what we did here is we changed the given quadratic function into standard form, and then we found everything. So once you get the standard form, you can write the vertex. Once you have the vertex, you get a lot of information, okay. So once you get the vertex, what I suggest is just draw this sketch, so that way it's easy for us to write the domain, range, where the function is increasing, decreasing, where it's the maximum or minimum. So everything, these sketch makes everything easy, okay. So make sure that you draw that sketch. Okay, now let's see what we have next. So the next one, so sometimes changing a quadratic function given in general form to standard form might be a little bit challenging when you have to do that completing the square. So if you don't want to do the completing square, if you want to go with the easy way, we have a formula to find the vertex. So we always don't have to do the completing square, okay? So there is a formula. So this is the formula for the vertex. So -b/2a gives us the x coordinate of the vertex, or if we represent vertex by h and k, then h is -b/2a. Now you don't have to really remember this one, because once you get h, you are going to plug that into your function and find the y value, and that gives us the k value. So that gives us the vertex, okay? So using this vertex formula is super cool, I mean super easy than doing the completing square. So let's go ahead and look at an example. So here we have a function, again in general form. So the first thing we are going to do is we are going to find the vertex. Okay, sorry, so this, we are not going to do this one. That was for the previous question. So we are not going to write it in vertex form, okay? So ignore that question. So we'll just find the vertex using the vertex formula. So finding the vertex, so we are going to use the vertex formula, which is the h coordinate. So let's go ahead and find that. So the h coordinate is given by -b/2a. Okay. Now here b is 4, so -b means -4 over 2 times a. The coefficient of x squared is just 1, and that gives us -2. Now the k coordinate or the y coordinate of the vertex is given by just finding the value of the function at -2. So k equals f of -2, or which is -2 squared plus 4 times -2 plus 3. And then if you simplify that, so you're going to get -1, because this is 4 minus 8 plus 3. That means the vertex, the coordinates of vertex are -2 and -1. So -2 comma -1 is the vertex. Again, once you get that, what I always suggest is just go ahead and draw the sketch. This is positive here, so that means it opens up like this. And we have the vertex, which is -2 comma -1. Now the axis of symmetry is the line going through the vertical line going through the vertex, which is x equals h, or x equals the x coordinate of the vertex, which is x equals -2. Now to find the max or mean, we just look at the graph. This is opening up, so that means we have a minimum, and the minimum value is -1. So this has a mean which equals -1, and that occurs at x equals -2. Now again, y-intercept is this coordinate here. So y-intercept is 0, +3. Sorry, it's not -3, +3. And then for the x coordinate, we have to solve that quadratic equation. Let's go ahead and do that in the next page. So we have x squared plus 4x plus 3 equals 0. So we're trying to find the x-intercept. So that means we are going to factor this. So you can factor this as x plus 3 times x plus 1 equals 0. And that gives us x equals -3 and x equals -1. So the coordinates of the x-intercepts are -3, 0 and -1, 0. So that's what we are going to put here. So the x-intercepts are -3, 0 and then -1, 0. Now again, the domain of the quadratic function is a polynomial function, so it's all real numbers. And for the range, again, we are going to look at the graph. So this is the lowest point on the graph. That means all the y values are above that point. So from -1 to infinity. Now again, the function is increasing on this interval right here. Okay, this part is the increasing part. So the x values for that part are from -1 to infinity. So it's increasing. Okay, so increasing on the interval -1 to infinity, and it's decreasing on the interval left of -1, which is -infinity to -1. Now again, to graph this, we are going to do the same thing that we did in our previous example. So first we are going to plot or graph the vertex, so which is -2, -1. So right here. Then we'll put the x-intercept, which are -3 and -1. So -3, -1. And then the y-intercept is 3. Now again, the axis of symmetry is right here. This is the axis of symmetry. That means we have a point that is 2 units to the left, to the right of axis of symmetry. Then that means we should have a point 2 units to the left of axis of symmetry right here. So now we can go ahead and graph this as a nice graph. My graph does not look nice, but that's how it's going to look like. Okay. So that's how we find the vertex, all of the information for a quadratic function, and then we can graph it using the vertex formula. This is a little bit easier than the previous one where we have to do the completing square. So yeah, you might want to do this way than the other way. So the next one is if you are given a graph, just looking at the graph, we can write the equation of the function, okay, quadratic function. So usually in this case, since we know the vertex here, okay, so we have this coordinate for vertex, which is 1, -4. Since we know the vertex, you might want to start with the vertex form or the standard form of the equation. So let's go ahead and do that. So y equals a times x minus h squared plus k is the standard form of the quadratic function. Now here we know the vertex, so let's go ahead and substitute h and k. So this gives us y equals a times x minus h is 1 squared, k is -4, so -4. Now all we need to do here is we need to figure out what this a is. So we need to find the value of a. Now what we do is you can pick any point on the graph, okay, and then plug it in and then find the value of a, okay. So I'm just going to pick this x-intercept here because it's easy. The y value is 0. That makes our computation a little bit easier. So I'm going to pick this point, which is 3, 0. Now the x value is 3, y value is 0. So that means if I put it here, the y value is 0 equals a times x value is 3 minus 1 squared minus 4. Now the only variable that we have here is a. That means we can solve for a. So 0 equals 3 minus 1 is 2 squared is 4. So we have 4a minus 4. Now if we add 4 on both sides, so we get 4a equals 4. And then if we divide by 4, we get a equals 1. That means the value of a is just 1. Now we can write our equation as y equals a is 1, so we really don't have to write. Then x minus h is 1 squared plus k is negative 4. So this is the equation for that quadratic function. Or if you want to write that as a function, then we can write f of x equals x minus 1 squared minus 4. So that is the function whose graph is given right here. So let's look at one application type of problem here. So we are given a function here. This function gives us the profit from a sale of some product. So this function gives us the profit, okay, where X is the number of products produced and then sold, okay. So now the first question is find the vertex and determine if the vertex represents a maximum or minimum. So let's go ahead and use the vertex formula here. So again, remember the vertex formula is negative b over 2a. Then whatever we get here, we'll put that into our function to get the y coordinate. So let's go ahead and find the x coordinate of the vertex, which we usually represent by h. So h equals negative b over 2a. So here b is 50, so negative 50 divided by divided by 2 times negative 0.5. So that gives us, so negative 0.5 times 2 is negative 1, so negative 50 divided by negative 1 is 50, okay? And then the k coordinate is given by half of 50, which is negative 0.5 times 50 squared plus 50 times 50. And then when we simplify this, we get 1250. That means the vertex for this function is 50, 1250. Now, since the leading coefficient is negative, so the graph looks like this. Okay, so it's opening down. That means we have a maximum. So the vertex represents the maximum value. Okay, so we have maximum. Now the next one is, it says sketch the graph. I have graphed the function and written here, but you can just sketch the graph. You don't really have to use a calculator here because we know the vertex. We can find x-intercept. In order to find x-intercept, you can just take this function, the expression, and then you can set it equal to 0 and then solve for x. So if we do that, so negative 0.5 means negative 1/2 x squared plus 50x equals 0. And then if we factor out x, we get negative 1/2 x plus 50 equals 0. From here, we get x equals 0. From here, we get 1/2 x equals 50, and then that gives us x equals 100. So the x intercepts at 0 and 100. The vertex is 50, 1250, and the y-intercept is 0 because the constant here is 0. So that means we can draw the graph. So the x-intercepts are 0 and 100, and then the maximum goes up to 1250, and the maximum occurs at 50. So our graph looks like this, okay, and then it goes forever and down. So this is the vertex. So that's how we can draw the graph, but I already have here from the calculator, okay. Now it's saying sketch the graph, and then it's saying interpret the vertex in context of the application. So this in the context, the vertex represents the maximum profit because that function, the value of the function is the profit. So it says the maximum profit occurs when we produce and sell 50 products. Okay, so the vertex represents the maximum profit. Okay, and the maximum profit is $1,250 when we produce 50 products or 50 items. So that's what the vertex represents. Now, for what x values is the function increasing? And for what x values is the function decreasing? And what does this mean with the context of the application? So if you just look at the function, so it is decreasing from negative infinity to 50 and then increasing. So this is decreasing and it's increasing on the interval from 50 to infinity. But if we go back to our context, so negative infinity, any negative number is not possible. So we never produce negative number of items. So usually when we write decreasing, sorry, this is increasing. I made a mistake. So it's increasing here and decreasing here. Okay. So, but in the context, we have to start at 0 because if we don't produce anything, that's 0, but it's not negative number of items. So from 0 to 50, so this is the interval where the function is increasing. Okay. And then from 50 to now we can write infinity because we can produce as many as we want. So this is the interval where the function is decreasing, and this is the interval where the function is increasing. In the context, this means the profit increases if we produce, okay, the number of items that we produce are between 0 and 50. Okay, so if you increase the number of products from 0 to 50, the profit is going to increase and it will reach maximum at 50. And then if you produce and sell more than 50 items, then the profit is going to go down. And then eventually, if you produce 100 items, the profit is going to be 0. There is a break even. And then after that, it's going to be negative. So that's what this says. Okay. So that's all for this video. We'll continue with the polynomial function. Rest of the things on polynomial function in the next few videos. But for the quadratic, we'll just stop right here.